All right, this video is going to cover complex zeros. Basically, what a complex zero is would be like 5i or like 2 minus 3i. Generally, something you would get if you had to run like the quadratic equation or something, and it got a negative root. These can get really ugly, and it's really important to watch your plus minuses and watch your negatives mainly. All right, let's just see some examples. One more piece of information though, before we even start, if they tell you like you have a 0 at 5 and 2i, anytime you see something with an I, the negative version of that will also be one of the zeros. So like another example, if it said it had zeros at negative 7i and 5 minus 2i, basically the negative 7i means you would have a 0 at positive 7i, and the 5 minus 2i, imagine that this part is like in the quadratic equation. It's usually like a plus minus right here, right? So my other one would be 5 plus 2i. All right, so that's just, I know you're probably already confused, but that's just some background information. Let's look at some examples. The way that they're going to word these is they'll say something like, find all the remaining zeros of the function. And so sometimes they'll be like, all right, my function is degree 5 with zeros, and then they'll list the zeros. So like maybe they gave you 1i and 2i. Don't overthink this. It's degree 5. You have 3 of them right there. And I just told you anything with an I, just hit it with the negative version as well. And now look, I have 5 zeros, so it matches my degree 5, and I would be done. Those would be the remaining zeros, the red right here, negative I and negative 2i. So sometimes they can be really easy like that, but sometimes they'll do stuff like this. They'll give you the equation like f of x. Let's do this one. All right. And they'll tell you a 0 most of the time. If not, you have to run PRZ. They'll give me 2i. Okay, here we go. First of all, you see a 0 with an I, put the negative version of that as well. This is one of your zeros, negative 2i. So this being degree 3, I have 2 of them right here. I'm only missing 1. Here's how you would get the next, or that last one. You have to run synthetic division with the I. So I'm going to start with this 2i first. That's what's going to go here. Now this is going to be pretty weird, so pay attention. The first number gets dropped. Then I multiply. These are not like terms. You cannot combine them. So you just write it like this. Negative 4 plus 2i. All right, before I go any further, you need to realize that I times I is the same thing as I squared, which has a value equal to negative 1. It's a sign changer. When you have an I squared, it's a sign changer. So the reason this is important is I'm going to have to multiply this times 2i. So it's going to look like this. Let me get rid of that. It's going to look like this. 2i times negative 4 plus 2i. And you're going to have to distribute. And so when you distribute to the second one, you have 2 times 2 is positive 4. So it's like plus 4. And then I makes I squared. Well, this I squared part changes this sign right here, this plus. This becomes this. it changes the sign and it disappears. So really, you could rewrite this like this. So that's just something to think about. You're going to have to multiply. And when you do that, you're going to have to distribute here. And when you do that, the I squared part changes the sign and drops out. Okay, so just keep that in mind. That's how I'm doing this. Let me back up a little bit. Okay, here we go. So I'm now multiplying this and this. I'm going to distribute the 2i to everything. So it's like minus 8i. And 2i times 2i is 4i squared, which is negative 4. All right, the 4 and the negative 4 can combine, and it'll just leave the minus 8i. Multiply it again. 2i times negative 8i is negative 16i squared, which is positive 16. So this is what I get when I run synthetic division on the positive 2i. Now, what I'm going to do, since I knew this negative version of it was one of the zeros, I'm going to immediately run synthetic division again on this result, this time using negative 2i. So drop the 1, multiply. You'll notice that the i's cancel kind of thing. When it's all said and done, you end up with your last factor. So the 0, the remaining 0, would be 4. So all of the zeros are 4, 2i, and negative 2i. Your teacher will probably let you get away with writing plus minus 2i. Just make sure there's a comma there. Okay, let's look at one more. This would be not worst case scenario because it could always get worse. But this would be considered a very difficult problem. Okay, imagine you saw a problem like this. They give you this super long polynomial and they give you one of the zeros. So there's 3 missing. This is a bad situation to be in, but I mean, it could, when I say it could always be worse, they did not have to give me this 0. They could have said, find all the remaining zeros without knowing one of them. And I would have had to run PRZ, and it could have even been more difficult. But this time they gave me one of the zeros, which is helpful. So the first thing I would do is I would realize the negative version of this is also a 0. So positive 2i is one of them. So I really only have 2 left. Now I'm going to start synthetic division. One thing I will say, I see a lot of students miss negative signs when they do synthetic division. Please keep an eye on that. All right, I'm going to do negative 2i first on this synthetic division. So that goes here. It doesn't matter. If you know 2 of them, it does not matter which one goes first. I could have definitely done positive 2i first. Won't matter. But I'm going to do negative 2i first. Again, these are not like terms. You cannot combine them. So you just write 5 minus 4i. This is the hard part, doing the multiplication of this and this. So I'm going to have a negative 8 and a minus 10i. Here's why. Distribute, you have the minus 10i part, and then it's plus 8i squared, but I squared has a value of negative 1, so it's really like negative 10i minus 8. So that's how I'm getting this answer here. I'm not going to show my work for that anymore, so I hope you understand that concept. All right, combine. These are like terms, the 5 and the -8, so I can combine those, but I can't mess with that minus 10i. Okay, keep going. All right, so this is what I get when I did synthetic division on that first one, using -2i. Now, since I know one and the other zeros, I'm going to immediately run synthetic division again, this time using +2i. So it'd look like this. You're looking for things to cancel. When they cancel, it's a good thing. You're doing it correctly. See, it cancels here too. That's keeping me on the right path. I know I'm doing it correctly when I see those cancel. All right, so now you get to here. The reason that this one's a little more challenging than the previous problem is because now I've got a trinomial, but you should always look to see if you can factor when you get to like this location here. So if you look to see you can factor this, you can factor it. It turns into 2x minus 1 and x plus 3. So in terms of factors, let's write it out over here. If I wanted it factored, I would have the two red ones that I just got at the end. But that's only two of mine, and remember, this was degree 4, so I need two more. It's these, the ones with the I. So it'd be like x minus 2i and x plus 2i. Now, in terms of zeros, that's when it's just 2i, negative 2i, and then I would set both of these equal to 0 and solve it. So you would get 1/2 and you would get negative 3. So zeros is x equals all these numbers. Factored form would be like f of x equals all these factors. Just be careful when you do this synthetic division. Hope that video helped.